Okay, everybody. Today we're going to be learning about curved mirrors. So this is going to go right along with the notes that we have in Google Docs. This is section 3. I'll write that at the top here if you're trying to refer back to that. 13.3, curved mirrors. So let's imagine we have a sphere, and inside that sphere is a mirror. That's going to represent one type of mirror, which is called a concave mirror. It's a mirror whose reflecting surface is the inside. So I'm going to draw an example or a drawing of a concave mirror. And if we imagine this is the inside of the mirror, this is the out or the back side of the mirror. And then I'm also going to draw, when we have a concave mirror, and I'm doing this without a ruler, so keep that in mind. This is the inside of the mirror, so this would be the mirrored surface. If we put an object in front of that mirror, like right here, here's our object. This would represent the object, the arrow. Concave mirrors can be used to form real images. Remember, those are images that are formed by the intersection of light rays, and they can be projected on a screen. Later on, I'm going to do an example and show you this projected image, but that'll be in a later video. So we can do what's known as a ray diagram to figure out where the image would be located, the reflected image, but we can also use a math equation to find where the image would be located. That formula is known as the mirror equation. The mirror equation has to do with the object distance, the image distance, and what's known as the focal length of the mirror. So the mirror equation is 1 over P plus 1 over Q equals 1 over F. P is the object distance. Q is the image distance. And F is the focal. We call it the focal length. You could also call it the focal distance. All three of those need to be measured in the same unit, so they could all be in centimeters, they could all be in meters, but they all need to have the same unit. The focal length is based on the shape and the size of the mirror, so that depends on the mirror. The object distance is going to be the distance of the object to the mirror. So if we measure the distance from here to the mirror, this would be P. Q would be the distance from the image to the mirror. Now that's going to be a little bit different. I could quickly, so we're going to say this is our image here. Don't worry about how I got that, but if this is our image, the distance from the image to the mirror, that would be Q. And then, like I said, the focal length is something inherent to the mirror that you would either calculate for or you would be given. When the distance is in front of the mirror, so remember this side is in front of mirror. This side is in back of mirror. When the distances are in front of the mirror, those are going to be positive distances. So in the front positive. In the back, negative. We can also figure out the magnification from these mirrors. M is the magnification, and it's equal to h prime over h, or you can use negative q over p. So it's a ratio. We'll write down what those are in a second, but it's a ratio of the distances of the image to the object distance. H prime is the image height. H is the object height. So if we had the if we had the object and the image and they were both the same size, the magnification, M, would be equal to 1. That's what we get with a flat mirror. With a curved mirror, we can get different magnifications. If it's greater than 1, it's making the image appear larger. If it's less than 1, it's making the image appear smaller than the actual object. So you see these equations here. Now, I want you to notice with this mirror equation, we're using fractions. So to put this into your calculator, let's just make up some fake numbers, and then I'm going to show you how I would like you to plug it in. So let's say P is 4 centimeters. Q is what we're trying to find, and F is 2 centimeters. Okay? So if we had those numbers and we plugged it into the formula, this formula up here, it would be 1 over 4 plus 1 over Q equals 1 over 2. Now you could probably do that in your head, but let's not do that. We're going to show you how to do it on your calculator. So I'm not going to zoom in. I'm going to go back and forth on this. But in order to do this the easiest way, let me move this over. Sorry. Remember to find the answer. 1 over Q would equal 1 over 2 minus 1 over 4. That's algebraically how we would find it. So how do we do that? We're going to hit our 2. And then up here, see this x to the negative 1? That makes it 1 over 2. It's just an easier way to do it, and we don't have to worry about using fractions on our calculator. So 2 to the negative 1 minus 4 to the negative 1, hopefully you guys can see that, is going to equal this. So that tells us, just as a reminder, that tells us that 1 over Q equals 0.25. But we need to find what Q equals. So in order to do that, it's actually pretty simple. We take this answer that we already have up there, and all you need to do is hit that x to the negative 1, and it gives you your answer to the negative 1. You hit enter, and it gives you 4. So Q equals 4 centimeters. And if we know anything about fractions, we should have been able to solve that anyway. Hopefully that makes using the mirror equation a little bit easier when you are working on your assignment.